Hey dosers, what's up and welcome back to another video. Today we're going to be focusing on part 2 of chain rule differentiation. So what does that mean exactly? So let's get right into chain rule first. So this is just a little bit of a recap. This is essentially just a harder type of chain rule differentiation. We'll be doing a harder question and there'll be a harder homework for you guys. So just to go over chain rule in general, if you have the function h of x and it's equal to f of g of x, or f and bracket inside inside of f of x is g of x is inside of f of x, how would you differentiate h of x? Well, the chain rule allows us to differentiate by stating that f prime of g of x times g prime of x is h prime of x. So h of x differentiated is essentially this. This is our rule. And a simpler way to understand this is given over here. Please pause the video, have a read of it. It's basically the same rule written over here. This is just another form. Don't get confused, but mainly just focus on this last part over here. It's the same rule, just written again. Okay? Now, what we were trying to do from before. Now, this is a little bit of a harder question, and if you haven't watched this video on chain rule differentiation, I'd advise please going back and reading through that before attempting this question over here. So just pause the video and have a go at this question now. Okay, hopefully you've had a go. So now this is a little bit more different from most of the questions that we've encountered in the past, and you might have encountered in the past. But to tackle this question, what you have to do is you have to remember that you are going to be applying chain rule over here because you do not have anything in the terms of x to the power 4 times by let's say 5y cubed. If you had these two terms, then you wouldn't be you would not be able to apply chain rule over here. You could not, because these two terms are completely different and it's a multiply in the middle over here. You'd have to apply product rule over here to differentiate. It would be way more complicated than this. Or if you have something like cosine x times sine x, these two have the same terms, but they cannot be combined, and there's a multiple. So how would you differentiate these two? And because of this multiply, we cannot apply chain rule again. But in this case, we have subtraction in the middle over here, but we have a square root on the outside. But that still means we can apply chain rule. So how would we do this? Well, first we have to make it in terms of f of x, f of u, and g of x. So we have to class our terms. So we're going to first rewrite this term. So we can write this as 1 minus x, and the square root essentially means that it's a power of a half. And this is in the same way, if it was 1 over 1 minus x, this would essentially be 1 minus x to the power of negative 1, because the negative implies that it is the bottom denominator and the half means square root. Okay, great. So y is equal to 1 minus x to the power of 1 half. Now that we've written this in terms of this, what can we do from here? Now we class our terms. So we write f of u, right? Our u being, you'll find out soon. So f of u is equal to u to the power of 1 half. That's what we're writing our f. So we've essentially just replaced 1 minus x with u. It helps us to simplify these terms and helps you to understand it better. And then we write g of x as 1 minus x. Now this is just to class it. It's essentially the same thing. 1 minus x is u, but because most of the chain rule differentiations are written in terms of f of x and g of x, I'm just writing this in terms of g of x. Okay? So once you've classed the terms, what do you do from here? Well, again, differentiate. Always write down what your differentiated terms are. Your variables here, f of x and g of x, differentiate them and see what happens. So this becomes 1 half u to the power of negative 1 half. Yes? And g of x, g prime of x becomes, what does it become? It becomes 1. Yeah, negative 1. Negative 1? Yeah, negative 1. Yeah, I was tweaking. Sorry, my bad. Yeah, it just becomes negative 1 here. So once you find out these two terms, what do you do from here? Well, you apply the chain rule, which is f prime of g of x times by g prime of x. Yeah? So we apply this now. So f prime of x. So that's just u to the power of 1/2, right? But remember, we're replacing our u now. Now is when we replace our u's. Find u as 1 minus x or g of x. This can be either g of x or u. You can class this as both of them. But when we're writing down the chain rule, so first thing that we do is that we replace our f prime of x. So 1/2 u to the power of negative 1. So what does that mean? That means that this is equal to 1/2 of u, which is 1 minus x to the power of 1. So you can write that as 1/2. For now, you can write it as this, 1 minus x to the power of negative 1/2. Yeah, we'll write it in the fraction term later. And then we times this by prime of x. Yeah, g prime of x is negative 1. Bam. That's our chain rule written. Because g of x was 1 minus. This is why I classed this as g of x. I didn't write u is equal to 1 of x. I wrote it so that you guys would understand that I'm replacing the u over here. But when you're writing down the chain rule, it's always given in this form. You never use variables like u. Only when you're substituting do you use variables like u for your f of u. Okay? That's not to confuse you. I hope that makes sense. And then once you class these terms, what happens is that this is still a square root and it comes to the denominator here. So this becomes negative 1, add negative 1 times 1 becomes negative 1 over, because this is the denominator now, it becomes 2 square root of 1 minus x. Bam! That is your chain rule applied in a different scenario, a little bit harder over here, but hopefully that made sense to you. If not, please do rewatch the video. It will make sense for sure. And if it helps you, please watch the first video again. It's going to be in the description below. Um, this is some homework for you guys to attempt. Please do it. It will really, really help you and really enhance your learning, especially for maths. And hopefully these videos are enjoyable for you guys. Thank you so much for watching today's video. I hope you've understood everything. Take care and have a good one.